Now we want to look at graphs of hyperbolas. Now a hyperbola has an equation that's in this form. It's x times y equal to c, or y is equal to c over x, where c is some constant. So just a number. Now, it's different from the other ones we've seen because there's no squareds there. There's no x squared, y squared, and it's that x and y are not separate terms. They're one term because they're together multiplying. So that's why it's a little bit different. Now we've seen a few of these types of situations um, when we've been looking at the domains and ranges, because obviously, hopefully, when you're looking at this one, you're going to see that you're going to have a restriction in your domain because you won't be able to divide by 0 there, so x can't be 0. So what are the other features of this graph? Well, it gives us a graph when it's positive, positive c on x, that's going to be in the first and third quadrant. So what do we mean by the first quadrant? Well, that would be the first quadrant, that's the second, that's your third, and that's your fourth quadrant. So it's going to be in the first and third quadrants. So it could also be in the second and fourth quadrants if it's a negative function. So that's just what we're going to do. That's what we're going to say. And we're going to have asymptotes. Now, what is an asymptote? It's basically a value of x or y that the function cannot equal. On the graph, we represent it as a line. So, you can see in this one, we said x can't be equal to 0, or y won't be able to equal to 0 either in this case. So that's why we're going to get asymptotes at the x and y axes. Now, if it's in another form, then we might see we will have to have another line being an asymptote, but that's okay. Now, how do we get the equation of this graph above by looking at it? Well, all hyperbolas have this form. You've got the two arms, asymptotes, and really it's just a case of going, well, what's our relationship between the x and y values? So if I pick that point there, you could see that it must be the point 2, 2. And what points multiply to give you, what are these 2 points multiply? Because remember, it's in the form x times y equals a constant. So if we got 2 times 2 equals the constant there would be equal to 4. So that's why we're able to get x times y is equal to 4. You can see the other ones. Minus 2 times minus 2, minus 4 times minus 1, 4 times 1, 1 times 4, 8 times a half, although it's a little bit harder to see. So you can see that the relationship there gives us x times y is equal to 4. Now when we start to draw these up, pretty much they're all going to be in the same sort of form. They're either going to be in those two quadrants or these two quadrants together, depending if you can see that they're in those quadrants because of the negative. And really it's just a case of you could almost draw the same graph up every time and just change your values and the scales on your axes. Because all you've got to do is get some points that are going to be relevant there. That's going to go through 2, 1, because 2 times 1 is 2. So when x is equal to 4, y would be equal to a half. X is equal to a half, y would be equal to 4. So you can see how we're getting that symmetry. It's actually going to be symmetrical about the line y is equal to x. But more about that later. Okay, and then same thing with this line, except it's different. It's in the different quadrants. But again, minus 1 times 5, minus 5 times 1, and the curve bends in between there. So we're going to look at doing that every time. So 1 over 2x. We could write this as y is equal to a half times 1 on x as well. So that we could write that. So basically it's half of what 1 on x would be. So again, if we drew 1 on x up, then we get half of that. So instead of being at 1, 1, it's at a half, half. So x is equal to 1 would be equal to half, so it won't be at half, half. And then x is equal to a half, y would be equal to 1. So again, get the same shape and just adapt our values. This one's a little bit different because we look at x plus 1 in the denominator there. We know from work we've done in our domain that x won't be able to equal minus 1. And y for our range won't be equal to 0. That's why we start to draw this line here through minus 1. Because the axis before on the other ones was the asymptote. But x is equal to minus 1 is the asymptote this time. It can't equal minus 1. So, but as x gets closer to minus 1, these values will start to get really small. So the values here, as it's close to -1 on this side, we get really small positive values. But remember, when we get 1 divided by a really small number, it starts to become really large. So that's why it approaches infinity there. And as x approaches infinity, that starts to become really large. And 1 over that value starts to be give us a really small fraction because the denominator is really large there. And the same thing happens on the y value, y side. It approaches negative infinity. That starts to be really small, but negative. So it's a really small fraction. As it approaches -1, we get a small fraction that's negative. So, sorry, it's a very small fraction that's negative. So 1 over that small fraction makes it a really large number. As we said, y can never be equal to 0. There's no value we can put in for x plus 1 and have 1 divided by something that would give us 0. So that's why we've got an asymptote at the y-axis as well. So more examples. You can see the asymptote hasn't been drawn up there, but it would be at x is equal to 1. X can't equal 1 there. In this case, x can't be equal to 4. And notice it's the y-axis because it's y's got no other relationship with it. It's just y there. The y-axis is becoming the asymptote it's still the asymptote every time. The shape of the curve stays the same. As it approaches the asymptote, it will approach infinity. As it approaches the y-axis, the y values approach 0. So, same ideas every time. What you've just got to determine is the asymptotes that we get, and whether it's in the first and third quadrants as such, or in that form, or if it's negative, which it shouldn't be. That should actually be a positive there for the graph we've drawn. That would be a positive one there. If it's negative, it should be in those quadrants there. So it should be looking at that every time. What quadrants is it in? What's the asymptotes? And the shape of the curve will remain the same all the time.